Hello everyone. Today we'll be presenting our Innovation Day idea for our engineering decision making with Python class. We'll be presenting an efficient model for predicting energy consumption using machine learning. And my name is Evan Cardona.
Hello, so my name is Safwan, and I'll be talking about the executive summary of our project. And the objective of our project was to analyze energy consumption data from Demovo Steel Co. Limited. Our goal was to identify patterns in how energy is used and to suggest strategies for improvement. In terms of methodology, we applied machine learning techniques to uncover insights from the data and forecast future consumption patterns. This includes using models like KNN and random forest to understand and predict energy behavior. The expected outcomes of our project was to find ways to enhance energy efficiency and support more sustainable practices within the steel manufacturing process. Overall, this study helped us explore trends in industrial energy use. By applying data science, we were able to assess energy efficiency, propose improvements, and generate actionable insights that could help reduce waste and optimize operations.
Hello, my name's Blaze. I'll be going over the background. For the steel industry significance, the steel industry is vital for modern infrastructure, significantly impacting both cost and efficiency. For data-driven optimization using Daywell Steel's real-time data, machine learning reveals insights to optimize energy use, reduce cost, and enhance sustainability. For energy consumption is a significant cost and efficiency factor in the steel industry. The steel industry plays a critical role in modern infrastructure. Energy consumption is a significant cost and efficiency factor. Using real-time data, machine learning reveals insights to optimize energy use, cut costs, and boost sustainability.
Hello guys, my name is Steven Estala and I will be going over the experimental test plan. The experimental test plan includes three key methodologies: random forest methodology, which improves accuracy by creating multiple decision trees to make prediction. The second one is K nearest neighbor, which improves the accuracy by using location association to test data and make predictions. And then for the final one, we use multiple linear regression, which is used to predict a continuous variable with more than one independent variable.
And for our experimental setup, we're first going to clean our data for preparation. The steel industry data was imported into Python and cleaned for usage, dropping the data that was not applicable, like dates, and changing strength variables to numerical values for testing, were some of the instances of preparing the data. The data was separated from the defined dependent variable y and the remaining independent variables x to analyze the test. For this, using a random state generator, we were able to split the data into four sets: testing data for x and y, which is the raw data imported, and the training data for x and y, which would use the raw data and random state generation to create data that would be fed to the model for training. After creating these, we scaled the independent variables by removing the mean and scaling the variance to avoid issues with the algorithm.
After that, we split off to talk a little bit about what we had to do for each of these regressional models to analyze these data for the different types of machine learning that we were doing. For example, for multiple linear regression, we first started by calculating the variance inflation factor, followed by doing the Verschuren-Pagan test, and then the Shapiro-Polk test to determine if the residual was normally distributed, so checking if the system was all right. And then the next one was the random forest regression, and using the random forest regressor, we were able to check its accuracy using R-square, MAE, MSE, and RME. And we were able to encode those into Python. And then finally, the KNN regressor, we used the K neighbor regressor, and we were able to fit the data for the KNN regression and then create a predicted output using the independent data.
My name is Cameron Chaddick, and I'll be talking about the experimental results. Our first model here is the random forest regressor, and we have predicted power usage versus actual power usage. And this graph is showing that all of the points are very close to the perfect fit line, which means this is a very good model. And our next model is the K-nearest-neighbor regression. And this graph also plots predicted power usage versus actual power usage. And shown here, all of the points are close to the perfect fit line, but they're more spread out than the random forest graph, so it's not as good, but still a very good model. And our next model is the multiple linear regression. We chose to show the QQ plot of residuals, and the graph shows here that the residuals follow the linearity line very well up until the end, where the residuals are very skewed from the line. And this, in combination with our R-squared values and MSC values, we can see that this is the worst model of the three.
My name is Asman, and I will be wrapping up with the conclusion. The random forest model stood out the most among all the methods we tested. It had the best results in predicting energy consumption, achieving a R-squared value of 0.99, which means the predictions were almost perfectly aligned with the actual usage. It also has low error rates, making it highly reliable for forecasting. We found that both KNN and linear regression also perform well, achieving a R-square of 0.98. So these models effectively captured the patterns in data, just not as well as the random forest model. And finally, we believe that there is strong potential in applying these models in real-time monitoring systems. If we integrated these into live operations, random forest could help industrial plants continuously track and optimize energy use. So overall, this project highlights the power of machine learning in energy management, and random forest is especially helpful for future industrial applications. Thank you.